Hi, in this video we'll talk about how to solve rational equations. The first thing we want to do is we want to completely factor all the denominators, not the numerators, but just the denominators. At that point, we want to make all expressions have common denominators, just like we did when we were adding and subtracting. We're going to solve the resulting equation in the numerator. The reason we can do this is that if all the denominators are equal, then the numerators must also be equal. For example, if we had x plus 2 over 5 equals 10 over 5, then what must be true about x plus 2? In this case, x plus 2 has to be equal to 10. Therefore, we can ignore the denominators once they're all the same. At that point, we want to check for any solutions that may be extraneous. What do we mean by these? We solve a simplified version of equation, but our answers may not actually satisfy the original equation that we started with. Let's look at two examples of rational equations. We have 5 over x plus 3 over 8 equals 61 over 56. We want to make all of the denominators the same. This denominator has an x. This denominator does not. So we're going to multiply by x on the top and bottom to make that denominator have an x. This denominator, 61 over 56, also does not have an x. So we multiply all those by x as well on top and bottom. This denominator has a 56. This one has an 8. We can multiply 8 times 7 to get 56. So we multiply the top and bottom by 7. 5 over x, we can multiply by 56 to get all the denominators the same. At this point, we got 56x in the denominator. 8 times 7 times x is 56x, and 56 times x is 56x. So we have 56x in all of the denominators. So we know the numerators must be equal at this point. 5 times 56 is 280. That's equal to 3 times x times 7 is 21x. No, I'm sorry, that should be a plus sign. 21x equals 61x. So we subtract 21x from both sides. So we get 280. It's equal to 40x. And then we divide by 40. So x equals 7. 280 divided by 40 is 7. We would check to see if that's an extraneous solution. We would plug 7 back into the original equation. So we get 5 over 7 plus 3 over 8. And we would check to see, does that in fact equal 61 over 56? Notice, this is the original equation is not the equation we solved. We solved the equation 280 plus 21x equals 61x. So if we were to check this out, it does in fact equal 61 over 56. So x equals 7 is good to go. What is the value of x in the rational equation? This denominator has an x plus 5. This denominator does not have x plus 5. So we're going to multiply this fraction by x plus 5. This denominator has x minus 2. This denominator on the left does not have x minus 2. So we're going to multiply by x minus 2. If the denominators are equal, the numerators must also be equal. So we get the equation 4 times x minus 2 is equal to 3 times x plus 5. We can distribute the 4. We get 4x minus 8 is equal to, distribute the 3x plus 15. We gotta get all the x's on one side, so we can subtract 3x from both sides. And at the same time, anything that doesn't have an x needs to go to the other side. So this minus 8, we can add that to both sides. So 4x minus 3x is x, and 15 plus 8 is 23. Again, we could plug that back into the original equation. We get 4 over 23 plus 5. Does that, in fact, equal 3 over 23 minus 2? That's 4 over 28, and 4 over 28 simplifies to 1 over 7. Does 1 over 7 equal 3 over 23 minus 2 is 21. So 3 over 21 simplified is also 1 over 7. So that, in fact, works. So x equals 23 is a solution.